Good morning, good afternoon, and good evening, depending on where you're joining us today from. We'll be starting shortly. Okay, so hello everyone and welcome to today's webinar. Before we get started, I wanted to go over a few items so you know how to participate in today's event. You've joined the presentation audio using the computer speaker by default, but if you would prefer to join over your telephone, just select telephone in the audio panel and the dial-in information will be displayed. You'll have an opportunity to submit text questions to today's speakers and key Docker experts by typing your questions into the questions panel of the control plane. You may send in your questions at any time during the presentation. There are a few of us ready to answer some of the questions, and otherwise, questions will be addressed at the end of the webinar. Today's webinar is being recorded, and you will have a follow-up email to view the recording. And I would like to now introduce your speaker, Elton Stoneman.
Hey, thank you very much for the introduction. Hi, my name's Elton. I work for Docker. Prior to joining Docker, I spent most of my career as a consultant in the .NET world, so building and delivering and managing enterprise .NET systems running on Windows. And then when Docker came along, I realized that everything would be Docker soon enough. So I moved to Docker, and now I spend a lot of my time helping people make their move to Docker. So today's webinar is focused on how to get existing applications to the cloud by moving them to Docker first. So the examples I'm going to use are all based on Windows Server 2000. Okay, so there's two parts to what I'm going to cover today. So the first part is looking at some of these apps in the Windows 2003 world, see what it looks like to deploy them currently and what deploying them looks like when you move to Docker. And then I'm going to show you the examples I've got of three different types of web apps. Static HTML, which is becoming having a renaissance with single page web apps. Classic ASP, so old style ASP apps written in VB script, and ASP.NET. So I'm going to show you a .NET 3.5 web forms app, and all those currently running in Server 2003, and I'm going to show you how they look in Docker. And then once they're running in Docker, the second part is to show you that you can run this stuff anywhere now. So anything that supports Docker, and that's Windows 10 or Windows Server 2016, you can take those packaged applications now, which have come from Server 2003, and you can run them on a cluster in your data center, or on the cloud, on a single VM, or on a cluster in the cloud, or a managed platform, or whatever you want. Okay, so there's quite a lot of stuff to do. Do please ask questions in the chat window. If we don't get time to answer them, we will do a blog post after this event where we'll answer all the questions that you posted. So if you've got a question, then please do fire it in. And you can also get hold of me at any time as well. Okay, so first of all, what does this look like when you're currently deploying Windows Server 2003 apps? So Server 2003, this is not meant to be a Windows Server 2003 bashing session at all. There are an awful lot of workloads still running on Server 2003, but now the year is 2018, so it's an old operating system. It's out of ordinary maintenance mode. So if you want support from Microsoft, you're paying an additional support fee for that. And there's no real easy way to upgrade from what you've currently got to the new world. And the deployment mechanism currently on Windows Server 2003 is going to be based off probably a Word document. So if you're deploying an application, the handover between dev and test, between dev and deployment is going to be a Word document with a whole lot of pictures in it, telling you what to click and what to do. And it's going to have a whole lot of instructions, which are mostly manual. So Server 2003 is a good example of an operating system where it's a little bit difficult to get any automation into your workflow. So you end up doing stuff like saying, log onto the server, copy the deployment artifact from some network share, so that'll be a zip file, an MSI, or whatever you're using to deploy, and then manually go through and configure the new deployment in RIS. So what you end up with is a few key artifacts, like a network share where all this stuff lives, a deployment artifact, a zip file or an MSI, and your server, and a human having to coordinate all those things. And that human has got to invest a whole bunch of time, potentially make some mistakes because a lot of this work is manual, and they need authorization to all these different things. And so it's a time-consuming and potentially problematic and security problem procedure. And what you get when you've done that, so the example I'll be showing you, you can run multiple applications in your Windows server, and they can be different types of web app running on IIS. So I've got my static HTML, classic ASP, and my ASP.NET. They can all be running on that same server. And actually, even though this is, a pretty old platform now, there are still some benefits to be able to running this model. So you can do things like you can run different types of technology. So a limited range, but you can run those 3 types that I've shown you. You can run them all side by side. And you've got a little bit of reliability and scale that comes to you from IIS and from Windows Server. So you've got worker processes that give you a little bit of failover. You can run multiple worker processes within the same box, which gives you a little bit of scale, but it becomes actually increasingly hard to scale out when you want to run on multiple servers, and you're limited to what you can do in terms of being able to run some sort of higher level to bridge multiple IIS servers. And the obvious downsides to this are right now, if you're running .NET 3.5 apps on Server 2003, there really is no potential to upgrade simply to a new version. You can do a lift and shift, and then when you've done that, you've moved maybe to Server 2008 or 2012 on premise. There's no portability there. When you want to move somewhere else, it's another project to get it moving up to the cloud. So what a lot of people are doing is moving to Docker first. And what I'm going to do now is it's mostly demos this session. So I had a few slides to start with. I'm going to switch to demos and show you what this stuff looks like. So first of all, just to show you this is for real, let's log in here. So this is a virtual machine. It's a Windows 2003 machine. It's been so long since I've used Server 2003. When I spun up this VM, I was creating a new VM. And halfway through, it says, please insert CD2, which was a reminder of years gone by. Okay, so this is just a virtual machine running on my machine. So think of this as a VM in my data center, a test server, or whatever. I've got IIS here. I've got my 3 sites running: classic ASP, static HTML, and web forms. I'm not going to show you all those, but just to prove that this really is Windows Server and not just a picture, I'm going to go and open Control Panel and open Windows Card Space. Anyone remember Card Space? So, okay, that's my source application. Those are where my apps are all living. And currently to deploy them, I've got to share, and I'm using zip files for all my deployments. Okay, so the first thing I want to do is move these things to Docker. So how do I do that? I need to write a Dockerfile. Dockerfile is just a script that tells me how to package up my application. So the Dockerfile for my classic ASP app, which I'm going to start with, looks like this. And it's really simple, and it's pretty easy to get started with. It's easy because it uses the tools that are native to the operating system. So in Linux, your Dockerfile will be mostly Bash scripts. In Windows, it'll be PowerShell scripts. So what I've got here is everything I need to do to replace my manual process to deploy this application. So the words in blue are the Dockerfile instructions. There's only about half a dozen that you need to know. And what I'm doing at the beginning here is I'm starting from an existing Docker image. So this is a Docker image that Microsoft own. It's got IIS installed on it. It's based on Windows Server Core, and it's the long-term support edition. So what this line here, this very first line does, is it gives me all the prerequisites I need for a Windows Server app with IIS running. When Microsoft do their monthly updates, their security patches, they release a new version of this image, which has got the latest security patches in. So whenever you build an image from Microsoft's image, it'll have the latest features of Windows Server 2016. One thing that doesn't come by default is classic ASP, but it's available inside the image. So the next thing I'm doing, this shell command incidentally just switches me from the ordinary command line to PowerShell. So I'm saying for the rest of the Dockerfile, use PowerShell. The run command is saying install the classic ASP feature, because it's not on by default because, hey, most people aren't using it, but it's there if you need it. So when you run up an image like this, you can run PowerShell to do whatever you need to do to set up registry settings or work on the file system or whatever you need to do. You can do it all inside the Dockerfile. So I'm adding the classic ASP Windows feature, and then I'm copying in my zip file. So I'm replicating what happens right now in production, where I've got a folder called share. I've got a zip file here with my classic ASP app. I'm copying it into the image that I'm building. This is the package of my Docker application. And then I'm running some more PowerShell, and that's just unzipping that zip file. So it's taking the zip file that contains my web app and it's putting it in a known place and then getting rid of the zip file because I don't need that inside my final package. And the last thing I'm doing is I'm removing the default website. So when you spin up IIS on a new machine, it creates that default website for you. And just like that, with the Docker image that Microsoft provide, the Docker package with IIS, it's already got that default website. I don't need that, so I'm going to get rid of it. So I know that the only thing that's in my container when it's running will be the things that I've set up. And the last thing I'm doing is creating a new website. So my web application is on port 80, and the path to my application content is this is on the C drive where I've expanded my zip file. So that's it. That's all I need to do. So if I've already got an existing artifact that I'm using, whether it's a zip file or an MSI or whatever I'm doing, just a folder with all my stuff in it, my Dockerfile to package that up and run it in a container looks just like this, and it's pretty easy to get started here. And you can see you can fit all this stuff into a CI process pretty easily. So that's my Dockerfile. So if I go here, I will show you how it works. So what I'm going to do here, this command here is Docker image build. So when you package your application in Docker, that package is called an image. The image is going to have a name. 6side is just my username, and then it's going to be called the classic ASP app, and this is the path to the Dockerfile. So that's the Dockerfile we've just looked at. So when I hit this, it's going to go and execute all the commands in the Dockerfile, and it's really, really fast because I've already run this before. So the output of this is an image on my machine. So this is a Docker image with this name, 6side / W2K3 classic ASP, that lives on my machine. I can start a container from that image, and I can push that image somewhere central, and anyone who has access can start a container from that image too. So let me start the container, and I'll show you what it looks like. I'm going to do Docker container run, and when you run a container, you can either run it interactively, so you can sort of connect to it. Let me just hide this out of the way here. Or you can run it in the background, and -D means detach, run it in the background, and that's the name of my image. So that's going to start my application container. It starts in a couple of seconds, and what that's doing is it's effectively the same as starting up a virtual machine that's already got your application installed and waiting for it to be ready. But with Docker, because I won't go into it today, but the way Docker works, the infrastructure of Docker is it's super lightweight. So you can start containers in a few seconds. So if I do this now, I can have a look at the containers that are running. So I list my containers. Oh, let's see, it didn't start. Why didn't it start? That looks a bit better. Okay, so let's go to my list. There we go. So I've got my container running. The way I've started this container with that really simple run command, I haven't made it publicly available. You'll see how to do that later on in the webinar. This is only available from my machine. So it's got an IP address, but it's an internal IP address. And I can see that by doing Docker container inspect. And 388 is the ID. I could give it a friendly name if I wanted to. And this is the address of that container. It's only available to me on my machine. We'll see how to make it publicly available in a second. So if I browse to that address, which was 32, then this is my classic ASP website. There's nothing to it. It's just a simple ASP page that spits out the server name. And the server name in the Docker world is the Docker container ID. It's the host name that the Docker kind of randomly assigns. So that's pretty easy to do. And what that's given me is a portable image where anyone who has access to that can run this in exactly the same way. Inside that Docker image has got IIS, it's got classic ASP platform installed, and my application. I don't have classic ASP on this virtual machine that I'm running the container in. That's all packaged inside the image. Okay, so we'll see a few more examples just to hopefully make it clear how all this stuff works. So I'm using Windows Server Core for this example. I'm installing the classic ASP Windows feature, and then just setting up my application. For my static HTML site, I've got a few more options. So my Dockerfile for my static HTML, it starts off, it looks very similar, but I'm using a slightly different starting point. So I'm using Nano Server for this. So if you've got Microsoft have two versions of server operating systems that you can use in containers. Windows Server Core gives you pretty much all of Windows Server 2016. So you can run .NET Framework apps, you can run Java, you can run classic ASP as we've seen, you can run 32-bit apps, pretty much anything that you can run in Windows Server, you can run in the Windows Server Core container. The other option is Nano Server, which is very, very much smaller. So the Server Core container image comes in at about 10 gigabytes because it's the full Windows Server. Nano server comes in at a few hundred megabytes. So it's got a much smaller attack surface. It's got a much smaller update surface, and it's much faster to move these things around if you can use Nano server. Nano server doesn't support 32-bit. It doesn't support full .NET framework applications. So there's a limit to what you can do with Nano server. But for a simple application like this, which is just static HTML, I can use IIS running on Nano server. And again, this is Microsoft's image. So what you want to do when you're writing these Docker files and packaging your applications is find the base image that matches your requirements, but is the smallest thing you can use. So I could use the Windows Server Core IIS image here, but it's going to give me a final application image that's bigger, slower to start, and more expensive to move around. Okay, so I'm using Nano Server. Again, I'm switching to PowerShell. I'm copying in my application zip file from the share, and then after that, it's pretty much the same stuff. I'm expanding the archive and removing the zip file. If you're more comfortable with batch files, you can do batch files in here if you want to, or you can run, you can put all these things into a script file, copy the script file into the Docker container, and run that as part of your Docker file. The last thing I'm doing is the equivalent of creating a new website in Nano Server. So for some reason, the PowerShell command that's in Nano Server is slightly different for IIS. So I'm removing the default website, and then I'm setting up a new website listening on port 80. And again, it's pointing to that static HTML application. So it's the same process to build that. So if I clear this down and look for 1.2, so Docker image build. I'm giving the tag is the name for my image. This will be the final output, the package of my application, and then the input is the path to my Dockerfile. So I'll run this, and again, this all comes from the cache because I've run it before. So I'm just going to briefly explain what that means because it's important to understand the efficiency you get when you're moving to Docker. So each of these lines in the Dockerfile executes and it produces a part of the final image. So the final image itself, which is called W3 static HTML, that's one thing. Logically, it's one very big file, but it's made up of smaller files, which are called layers, and they can be cached. So what Docker does is when it sees all these instructions, it looks inside its local cache, it sees if there's a match, and if there is a match, it will use it from the cache. It won't repeat the work if it doesn't need to be done. So if I show you this running again with the no cache option, it will execute all those steps. So it's going to run the PowerShell, it's going to copy in my file. So you see it's taking a few more seconds to do this stuff. It's expanding the archive here. So this is executing inside a container, and the output will be a layer that gets packaged up into my final image. So the reason this is important is if you write your Docker file in the right way, then only the things that change get actually executed when you do a Docker image build command. So you can fairly easily have a CI process that gets kicked off every single time someone pushes a change, but the build runs in a few seconds, and it pushes a version of your Docker image to your local registry. And again, all that stuff can just happen in seconds. So there it took a little bit longer, but if I repeat the command again with the cache, it's all done pretty much instantly. So that cache is a really useful feature. So I've got two images now that I've built. One is my classic ASP, and now I've got this static HTML. And the way I start this is exactly the same. Docker container run -d to put it in the background, and then give the image name. So this is based on Nano Server. So it's only got a 64-bit operating system. It's a cut-down version of the Windows API, but it's got IIS installed, so I can run my static HTML website in there. The way I treat this thing is exactly the same. So whether it's my classic ASP app running on Windows Server Core, or this application, or a Java application, I'm talking to Docker to start these things. And the stuff that the application needs to run is part of the Docker package, is part of the image. So now I have a new container. So I'll do a Docker container inspect again. Again, it's not publicly available because of the way I've started it, but it's easy enough to make it public if I wanted to. So let's get the IP address, which is there. My other container is still running, so I can refresh this. And if I open up a new tab, get rid of those quotes. And here's my static HTML. So this is just a single page application. It's a demo app to show you what some of the features are of this particular framework. But this is all just in HTML and JavaScript. So I don't need a complicated hosting platform. So I can just use static HTML, and then I get it running up in a container. So I don't have to care what's inside the image. I don't have to care what the platform is. I can just spin it up in a container and get it up and running. Okay, and the last example, which is probably the most common, at this stage, which is ASP.NET application. So this is a .NET 3.5 application. It's a web forms app, so it's a simple website. Again, the Dockerfile is very familiar now, so you see that there's not much difference between these things. Theoretically, it's pretty easy to write a tool that can generate these things for you, that you can point at a server and it can extract information out for you. But if you want to get started, it's fairly easy to just write these things or to go from examples. So again, I'm starting from a Microsoft image. It's based on Windows Server Core, but this time it's got ASP.NET 3.5 installed. So let's undo that, otherwise it won't work. It's got IIS, it's got .NET 3.5, and it's got ASP.NET 3.5 configured. So this gives me everything I need to run my what could be a 10-year-old application. Now my application, again, I'm copying it from a share. It's a zip file. It could be an MSI. I could be copying it from a remote location. I could, if I was moving more wholesale to Docker, I could build it from source inside the Docker file. So the first part of the Docker file, I would compile the application from source, so I wouldn't need a separate zip file. And the second part of the Docker file, I would package it up. But in this case, I'm assuming there's some sort of process that's already generated this. So maybe I've got a CI process that spits out a zip file or spits out an MSI, and I want to see what it looks like in Docker. So I'm copying my zip file, and then it's the same stuff. I'm expanding it, getting rid of that kind of intermediate deployment artifact, the zip file, remove the default website and set up a new website. The reason for doing this is that it's really clear what's happening. So if you think about the current world where maybe you've got a Word document or an Excel sheet that's telling you exactly what to do, those instructions are probably out of date. They're probably not explicit enough, or they're too explicit. So it's difficult to keep that thing maintained, and it's typically difficult to see at a glance what is actually happening. If I wanted to go and look at that application to find to try and debug a problem, I would need to know, what port is it on, where are the files stored, what application pool is it using. I'd have to trawl through the document to find that, or connect to the VM and trawl through it. I can see all that from the Dockerfile. So the Dockerfile is your explicit set of instructions of how this application gets deployed. Okay, and then to build this, it's the same thing. So again, different platform, different type of application, but I'm building it in the same way. So my 1.3 is Docker image build. I'm calling this one W2K3 web forms, and I'm pointing it to my Dockerfile. So the Docker files I'm using are really simple, and towards the end of the webinar, I'll show you what a production grade Docker file looks like, and it's not very much more different. So these are perfectly fine. They're all you need to get started. So now I've got my web forms app, and I can start that in a container in the same way. So Docker container run, put it in the background, and pass the name of the image that I've just built, which is version 1. And again, it'll start in a couple of seconds. The way that Docker starts these containers, the process running in the container is actually running natively on the host, which we'll see in just a second. So let me get the IP address. So container inspect 0cc. So these are like internal IP addresses that Docker assigns. Containers can reach each other if they're on the same Docker network. And if I'm on the machine, I can reach them by the container IP address. So this is my final application. This is my .NET 3.5 app. So this could be a 10-year-old app. My classic ASP app, which is here. This could be, I don't know, this could be a 15-year-old app, even older. This could be a brand new SPA. And here's my .NET 3.5 app. So again, it doesn't do a whole bunch of stuff. It's just a useful app for showing some features of Docker. But that's all up and running now. So I've got 3 separate containers that are running these applications. I can show you how all this looks on the server. So on the server now, this is my server. I can do get process and look at the worker processes. And you'll see I've got 3 worker processes here. And these are the processes that are inside the container. So each of those containers has an IIS worker process that's servicing requests. But here on the host, if I look at the services, W3, the IIS service on the host is stopped. So I don't need IIS on the host to be running. I don't even need to have it installed. Everything the containers need is inside that Docker image, and that gives us everything that the application needs to run. The processes themselves run natively on the server. So I'm on the server. I can see these 3 container processes. Inside each container, I'd only see one of those because the container is just a thin boundary around the processes that are running your application. Okay, cool. So That's the first part. So I've moved these apps to Docker. All this stuff's on GitHub. I'll share a link at the end. You can see all these Docker files. You can see all these applications, and it's pretty easy to get started. So my classic ASP, I'm starting from IIS. I'm just enabling the feature that I need and setting up my app. Static HTML. I'm using Nano Server on IIS on Nano Server because that's all I need. I don't need to add any features here because I've got everything that I need. And my Web Forms app, I'm using Windows Server Core with .NET 3.5 installed. So Microsoft are increasingly producing more and more images that give you everything you need to run your app. So your Dockerfile is just going to be the explicit steps to set up your own application. Okay, so let's go back here now. So what we have now, we've moved away from having a server with IIS with a few different websites on it. We've got a server that's got Windows installed and Docker installed, and that's all you need. So I don't need .NET on my server to run a .NET application. So I can run different .NET apps in containers and have different versions of .NET with no issues about them coexisting because they're in completely separate containers. Each of those containers thinks it's its own server. I'm running my web applications as containers through Docker, and each of those has got a different stack on them. So I've got my static HTML site, my classic ASP site, my ASP.NET site. There's a whole variety of things here, but the way I package them is with Docker files and the Docker image build command. The way I run them is with the Docker container run command. The way I manage them is through other Docker commands or the Docker API. So I'm adding a level of consistency to those completely different apps. So I'm going to work with them all in the same way. And those blue boxes that are showing the site, the static HTML and the classic ASP, those are the processes that are running natively on the server. And that's another major reason why people are moving stuff to Docker. So firstly, moving it to Docker means I can take it anywhere. I can move it to the cloud. But also if I'm staying in the data center or if I'm moving to the cloud, I can run a lot more containers on a server than I could on applications on a VM. So you can run as many containers as you like on one Windows server. You pay a single Windows Server license for the machine that's running Docker. And then if you can run 100 containers on it, then you save an awful lot of infrastructure costs on VMs, on licenses, and you can get a lot more density. Okay, so when we've got our Windows apps in Docker, I can pretty much run any server application, not just web applications. So these could be batch processes that are running in the background. They could be databases, anything that doesn't need a UI because there is no Windows UI in containers. So anything that I can run on a headless Windows server, I can run in a container. And it could be any technology. Like I've shown a variety of web technologies, but it could be Go, it could be Node.js, it could be Python, it could be whatever you want to package up. As long as you can write a Docker file that scripts the deployment, then you can put it into a Docker image and then you can run it in a container. The reliability and scale, which you kind of get from running in IIS, you've now got at a much higher level. So when these things are running in containers, it's easy to move them around. It's easy to start up multiple instances of the container. So you can have a cluster of machines all running Docker, and then you talk to the cluster and you say, here's my classic ASP app. I want you to run it on 20 containers across the cluster. And then you're not looking at individual machines to see where the container is running. You don't care about that. You're working at a much higher level of saying, here's my application, here's my web application, make sure it's up and running, make sure it's got the scale I need. And then the Docker platform will monitor your service and make sure that the service level is adhered to. So if a server is running a dozen containers, and that server goes down, then Docker will start up replacement containers somewhere else on the cluster. So you get a much higher level that you're operating these things. And this is Windows Server 2016. So you need, as a minimum, you need Server 2016. But actually, interestingly, going forward, ideally, your move to Docker should be the last migration that you need to make. So you should not at any point in the future need to say, now I've got my stuff in a Docker image, I need to rebuild it some way for some other platform. So Windows Server 2019 is coming soon. There are Docker in Server 2016 is really good, and in Server 2019 there are some really good improvements. So Microsoft are investing heavily in this. So you're going to be able to move your apps to Docker, and then if you're on 2016 now and you decide to upgrade to 2019 in a couple of years' time, you're just going to continue running your containers. You don't need to do any. You might want to rebuild your image. But that's up to you. But you won't have to do any additional work to work out your Docker file. And this stuff's portable now. So I'm going to show you that in a second. I've built my Docker image, so I've got my application package. That's on the machine where I did the Docker image build command, but I can share that by pushing it somewhere public. or private if I've got a private place to store those things. And anyone I give access to can pull that image and run the application, and it'll work in exactly the same way everywhere, because the whole application package, the default configuration settings, all the libraries that it uses, they're all inside that Docker image. So wherever you run it, it's going to behave in the same way. And that could be in the data center, on a single virtual machine, on a cluster of machines, any cloud provider that you can spin this stuff up on Windows 10, it'll all be exactly the same. So what does that move to the cloud kind of look like? Well, we've seen the first part, which is building your image. So on my machine that's running Docker, I've taken my Dockerfile, which effectively describes all the things that I need. So my Dockerfile, I've started with my ASP.NET image that comes from Microsoft. So the last 4 blocks in that diagram are given to me for free, and Microsoft maintain that. The only thing I've needed to provide myself is top layer, which is my own application. So these are the kind of this is the logical view of my Dockerfile. I run my image build command and I get an image, and that's either on my build server or it's on my developer's laptop or wherever they've done that build. The next thing is to make that available to a wider audience, and for that you need to push it to a registry. Now, a registry is just a type of server that understands Docker images. So the most popular one is Docker Hub, which is a free public registry. So if you've got open source stuff or you've got things that you want to share, tools that are generally useful, you can push them to Docker Hub, and anyone can use them and run them in a container. All the Microsoft images are up on Docker Hub. So those things that we've seen with IIS and ASP.NET, they're all on Docker Hub. They're all freely available to use. You can run your own registry instead. So for private projects, for your enterprise projects, you'll have your own registry. And that might be, you can run an open source registry in a container, or there are a whole bunch of commercial options. So Docker has the Docker Trusted Registry, which has additional security around that. I'll be talking about that in a later webinar. But all the registry API is an open API. So you can use anyone's implementation of a registry and be able to save your images in the same way. So Docker image push will take that image from your local machine and push it up to the registry, and then it's available to whoever has access. And then whoever wants to run it is going to run that same command, Docker container run, give it the name of the image, and then if that image isn't available locally, then Docker will pull it down from the registry and start the application in a container, just like I've seen on my machine, and it'll be the same wherever I run that. And I can run that on my laptop, or I can run it on a physical server or a VM in the cloud. It's always going to be the same behavior because it's exactly the same runtime. Everything the app needs is bundled into the image, and the Docker platform is making sure it all runs as it should. Okay, so let's show you that next part of how that looks. So I've got here, switch back to my developer VM. So this is the VM where I've been doing my Docker image build commands. I've got a whole bunch of images. I'll show you the whole big list, which is going to be a scary big list because I do lots of stuff here. But I can filter that. So this is all the images that I've either pulled from Docker Hub or that I've built myself. You can see here there's some other. This is my own local registry. So some of these things come from my local registry, and some come from Docker Hub. Let's run my 2.1. If I filter that image list, so I only include the things I've just built, so I can filter it by the image name, that will show me the things I've built today. So I've got my static HTML, my classic ASP, I've got a couple of versions of my web forms, and I can go one further, and I can filter that with, just get the repository name out. So I'm showing you this so you get a feel for the CLI. So the Docker command line talks to the Docker API. So Docker's running in the background, that's looking after all the containers and stuff. And there's a REST API that's available to talk to Docker to start containers or to query them. The Docker command line talks to that API, and because it's really easy to get information like this out, it's really easy to do automation. So if I now do my 2.3, what I can do is I can take that list of images from the Docker image list command. I've filtered it so I'm only getting the ones I care about, and I'm formatting it so I'm only getting the image name, and I can pipe that with PowerShell into a Docker image push command. So that's going to take all my images that I've just built and push them up to Docker Hub. And what you'll see is these here are all the image layer IDs. So I talked about the image layers and how Docker caches them, and it only builds the layers that it needs to. If it finds a match in the cache, it will just use it from the cache. The registries work on the same principle. So when you push to a registry, you're pushing a single image. So I'm pushing this first image, which is static HTML. But what Docker's actually doing is it's talking to the registry API and saying, here are all the image layers. and the registry API is either saying, yes, I need those, and they get pushed up. So in the first one that we saw the upload progress. That was the layer being pushed up. But for these subsequent ones that I've already pushed to save time, those layers already exist. So Docker finds a match, the registry finds a match, it doesn't try to push it again. So anyone who pulls it will use that cached layer. Okay, so to show you that, I'm showing you those command lines. So you can see it's really easy to integrate this stuff into an automated pipeline, which is almost impossible to do with the current way of delivering stuff in 2003 or 2008 in older server operating systems that were built for hands-on maintenance rather than automation happening somewhere else. Okay, so I've pushed those up to Docker Hub. So let me just go and show you my Docker Hub account. So I am side, what did I call it? W2K3 static HTML was one, wasn't it? Okay, so this is a public repository, so anyone can see this. These tags are the names of the image. So in this case, I didn't give it an explicit image version, so it just uses the latest name. And that's when I pushed a minute ago, it's 400 megabytes, because this is the IIS nano server image. This is a nice small image. If I show you my ASP.NET one, which was called, no, stop that, go back here. Let's grab the image name. And the image name was, here we go, W2K3 web forms. So this one will be much bigger because it's based on a bigger image itself. So W2K3 web forms. The tags for here, there are 7 gigabytes. So almost all of that is the base image. It's the Windows Server core base image that has all those Windows features available for me to switch on. That's why the base image is so big. It's got .NET 3.5 already installed. It's got IIS installed and ASP.NET already configured. So that's why those things are so much bigger. My own application is like a layer at the top of that, which is 10 megabytes. And the rest of it is coming from the Windows Server core image. But because of the way that the image layers are cached, I don't end up having multiple copies of the Windows Server image. So if I pull down both of these images on my machine, I'm going to have one copy of the Windows Server layers, and then one copy of my ASP.NET layers, one copy of the IIS layer, and then one copy of the version 1 application and one copy of the version 5 application. So if I've got lots and lots of images based on Windows Server Core, they don't all have a copy of that 6 gigabyte base image. They share one copy of that 6 gigabyte base image. Okay, so I've pushed this up to Docker Hub. So this is now publicly available. So if I switch to my separate VM, what I'm going to do is I've got a VM running in the cloud. Let me close this up. I'm going to run all those applications in one go. And the way I'm going to run them is by using a Docker compose file. So a compose file is your Docker file builds a single part of your application. And if you've got a distributed application, the compose file is how you describe all the bits that fit together. So in this case, I'm just running my 3 applications, my classic ASP, my static HTML, and my web forms app. So these are the image names. This isn't a distributed app, so these containers aren't talking to each other. I'm just using this as an easy way to group these things together. This is the equivalent of specifying a whole bunch of Docker run commands, Docker container run commands. But instead of having to run the command explicitly, I'm defining the desired state here. These ports are telling Docker which ports to expose. So previously, I had to go into the container's IP address when it was running on my dev machine. When I push this out to the cloud, I'm going to be able to access them by a public port. So what this is saying is when traffic comes into port 8080 on the host, send it into port 80 in the container. So I can do port mapping, I can expose a different port than is in the application, and I can manage things that way. So I've got 8081 for my static HTML and 8082 for my web forms. Okay, so let me switch now. I've got a VM running up in Azure. I'm using Dev Test Labs. There's a base image here. If you can see that particularly well, let's zoom in. The base image is Windows Server, let's go back, Windows Server 2016 data center with containers is what it's called. So if you spin up a VM in Azure and you pick that base image, you get Windows Server 2016 with Docker already installed and with the Windows Server core and with the Nano Server images already downloaded for you. So it basically gets you up and running really quickly with a Docker deployment. So I've started my VM running up in the cloud. I'm going to connect to that now, which is here. And if I do Docker version, you'll see this is running Docker on the server. The API is running on Windows, and the client is running on Windows. Docker is cross-platform, so I can use my Mac to manage my Windows server. I can use my Windows machine to manage my Linux server. I can use anything to manage my cluster. It's all cross-platform. Okay, so what I've got in here is I have got a copy of that Docker Compose file, which just specifies all those images that I want to use. And I've already pushed those images, so they're public images. If you want to run these 3 apps, and there's no reason why you would, then all you need is this Docker Compose file. So you can run the command which I'm about to run, which is Docker Compose up, which is telling Docker Compose to take that Docker Compose file, start everything up, and the -d is the same as the -d in the run command. It's going to start them in detached mode, so it's going to put them in the background. And you can run that command with this Docker Compose file, and you don't need anything else. Docker will pull all the images if it doesn't already have them running locally, it doesn't already have them available, and then it will start all the containers. So that's done. So if I do a Docker container ls, so these are all running now. They're the same image names. It's exactly the same images that I've pushed up to Docker Hub that I built on my machine. The only difference is now that these are publicly available. So I've exposed these ports. So it's saying that any traffic coming into 8082 on the host will go into my web forms container, 8081 goes into my static HTML container, and 8080 goes into my classic ASP container. So those 3 apps that were packaged to run on Windows Server 2003, I've used zip files deliberately to show that there's no difference in how I would deploy my artifact. I can use the same artifact on Server 2003 or in Docker. Those things are all running now in containers in the cloud. Okay, so I can prove that by going and making sure I can call these things. So where's my virtual machine here? This is the interesting bit. So I'm going to grab the domain name of my VM. What's happening here? I think the combination of running the webinar and trying to use the internet is slowing down my UK broadband. Okay, here we go. So that's my IP address. So if I browse to 8080, I get my classic ASP website. It's a different server name because that's the container name. If I browse to 8081, let's see 8081, I should see here's my single page application, my view application, static HTML, and then 8082 is going to show me my web forms app. So this is a little bit slower to start, and the reason for that is because of the warm-up of my container. So there's my .NET Web Forms app, my .NET 3.5 app up and running. So I've got a classic ASP web application. I've got some static HTML, and I've got my my ASP.NET 3.5 application all running now in the server in the cloud, which I can access externally. They're all running in containers. And if I wanted to move to a different region in Azure, if I wanted to move to AWS, if I wanted to move to Google, they all have images that have Docker pre-installed, and I can spin up a VM and run these same container images. I wouldn't need to change anything at all. I can use the same compose file. If it's a distributed app, I would use the same Docker images. So now my solution is completely portable. There are a whole other bunch of benefits as well, which I'm not going to particularly cover today, to do with the fact that I now have a consistent image format. So flipping back to my my images here. So I'm just using Docker Hub, but now all my applications live inside a common registry, inside one place where I can go and find all my web applications, whether they're classic ASP or whether they're ASP.NET 3.5. And because they live in a registry, if I was running my own private registry, because the image format is a public format, it's a well-known format, the registry, when you push your image to share it, it can do some additional clever stuff. Like it can break into the image, it can look at every single binary that's in the image, and then it will look at, so Docker Trusted Registry does this. When you push an image, it looks inside the binaries, tries to work out what every single file is, and then looks up against a bunch of known vulnerability databases, and it will tell you if there's a known security issue in some binary somewhere in your image. And that could be a third-party library that you're using. It could be something that's part of Windows. And it will tell you what the security issue is, and it will tell you what you can do to mitigate it. I won't cover that today, but I will cover that in the subsequent webinar I'll be doing in a couple of weeks' time. Okay, so back to the slides. Okay, so I've done the second part of this now, which is I've taken my applications, I've packaged them to run in Docker. I haven't changed the app at all, and I've just written some pretty simple Docker files and a simple Docker Compose file to be able to share these things around. By pushing it to the registry, I've been able to make it publicly available. And if I was using a commercial registry, I'll be able to take a whole bunch of other benefits from that as well. Anywhere that I run this is going to run in exactly the same way. So Docker in production, the only real difference is that I'm going to be running a cluster. So what I have now is I have a single virtual machine running up in Azure. That doesn't give me any failover. So I can start my containers such that if the server goes down, when it comes back up again, Docker will automatically restart them. And I can construct my containers in such a way that if there's a problem, they get shut down and Docker will restart the container for me. But if there's a problem with my VM and my VM goes offline, then all my containers are unavailable and all my applications are unavailable. So Docker in production, the big difference is you're going to run a cluster. So you can take a whole bunch of servers, and they don't need to be heterogeneous. So I can have a mixture of different operating systems here. So this example here, I've got 2 Linux servers running Ubuntu. I've got 2 Windows servers. I can join them all together to be one cluster. And I can tell Docker to run a mixture of applications now. So I can say, here are my classic ASP apps, and here is a brand new Node.js app written to run on Linux. And I'm going to deploy them to the same cluster. And Docker will work out where to run them, and it will work out how many containers to run based on the service level I've told it to use. Okay, so when I join them together, the clustering technology, I could use Docker Swarm, which is built into Docker. It's really easy to use, and it works really nicely with Windows. And I can run my classic HTML, classic ASP, and my web forms app, and I can run them all using the same Docker images. So this is an important thing. So when I'm packaging my applications to run in Docker, I build the image, and the image is the portable thing. So that's where when I run a container in production, I'm using the exact same image that I've used in my test environment that the users have okayed. It's the exact same image that's been through my automated tests, and it's the same image that was built from my source code by the CI server. Okay, so I could also use this cluster to run newer applications. So I could run ASP.NET MVC. I can even run .NET Core applications. So my .NET Core applications might be running on Linux containers, on my Linux servers, but I'm going to manage them all in the same way. I'm going to have Docker images, which have my applications packaged. It doesn't matter whether it's classic ASP or brand new ASP.NET Core running on Linux. I'm going to build them into images and store them in my registry. And I'm going to run them by running containers on my cluster. Okay, and if I want to get really fancy, then I don't have to be limited to running Docker Swarm. So if you've heard about this stuff, the Swarm layer is an orchestrator. So when you move into a production environment with a cluster of servers, you don't talk to Docker to run individual containers. You talk to an orchestrator, and you say, here's my container image, which would be my classic ASP image or my .NET Core image. I want you to run it across the cluster, make sure there's 10 containers so that I get high availability. And then the orchestrator takes care of that. Docker Swarm is one option. It's a good option to start with because it's really easy to use. And it has some opinions that make it really easy for you to get started with. The other big option is Kubernetes. So Docker Enterprise Edition, which is the kind of production grade clustering technology, it supports Swarm and Kubernetes. So if you want to use both, if you have teams who are already using both, then you can support that on a single cluster. So I've got one cluster with, in this diagram, 4 machines, but some of our enterprise users have hundreds and hundreds of nodes all in a single cluster. I can have some Swarm nodes, some Kubernetes nodes. I can deploy my existing applications wherever I want. So I could have some .NET apps which are monoliths, or whether they're been broken down, but they're still using the older full .NET framework. I can run those in Swarm, which currently has good Windows support, and they're going to run in Windows containers. And I might have a bunch of Java apps which are monoliths or partly broken down monoliths, They might want to run on Linux apps on Kubernetes. That's fine. They run on Linux containers on the same set of servers where I'm managing my .NET applications, and I've got a user interface which lets me manage them all in the same way. And I can be running cloud native applications here. And if I'm really interested in innovative stuff that's coming down the line, I can run serverless applications all on exactly the same cluster. And I'm managing them all at the same level. So I don't care whether it's a .NET monolith running on a Windows container on Docker Swarm, or whether it's a serverless platform running in Kubernetes on Linux. I'm going to manage it at the same level. So I'm looking at logs. I'm connecting to containers if I need to. I'm managing the images. I'm doing the security stuff. I'm working with the same set of principles, no matter what the application type is. Okay, the last thing I'm going to show you very quickly, because we're getting to near the top of the hour, is what the production Dockerfile looks like. So let's go back here. So going back to my .NET Web Forms application, the version 1 Dockerfile I have is it's very simple, it's perfectly functional, but it's a bit naive for going into production. What you can do with Docker is Docker lets you have cloud native applications, and the term cloud native is a bit loaded, but there are some really good definitions about what it means. So it means, if you look at the Cloud Native Compute Foundation, they have a set of definitions that it means about being container packaged, first of all, because containers are the core thing to be able to move all these applications around, start them up in a cluster. It means dynamically organized. So you have an orchestrator that looks after your application for you. You don't care about individual servers anymore. And you can't really do that easily with old applications because they're not built to run in containers. We saw when I started up my .NET Web Forms app on my cloud server, when it was running in a container, when I first browsed to it, it took a few seconds to get a response. And that's because of the cold start that we have with that particular application platform. So when you start a container with IIS, it's just like starting a virtual machine that has IIS. The IIS Windows service starts in the background, but it doesn't start a worker process to handle requests until the first request comes in. So that's the cold start issue. The first user that hits the cold website, the worker process spins up, the application gets loaded into memory, and then it serves a response. That sort of slow start is typical of older applications when the idea was you turned on your machine and it stayed on for 2 years. That's no longer the case with containers. But by constructing a more careful Dockerfile, you can take all the advantages you get with Docker and make your old app behave like a new application, make it behave like a good citizen in Docker, still without changing the app. So I won't go into too much detail here, but this is what a production-grade Dockerfile would look like. It's still not huge. There's more stuff in here, but we're still only sort of 40-odd lines. The important things are I'm still starting the same way. I've got my zip file. I've got my .NET. Is my base image. I'm expanding my archive. All that's the same. I've got a whole bunch of environment variables here. So what Docker can do is when you start a container, it can inject environment variables that get surfaced as Windows environment variables inside the container. And I'm using these environment variables to do configuration around my application. So my app has some logging set up. It has some connection strings to connect to a database. As it's currently deployed, it doesn't let you change those because it expects to find them in an XML file. What I'm doing with this Docker file is I'm injecting some configuration so I can tell it to get that information from somewhere else. Then I've got my new website stuff. And then I've got the other thing I wanted to show you is the health check here. So I've got a health check, which is a feature that's built into Docker that lets you, along with your application package, include some instructions that tell Docker how to test your application is actually healthy. So what this is saying is every 2 seconds, run this health checker command, which is just a .NET application that I've also packaged into my container image. And what that does is it checks the web application, it exercises a few paths through the website inside the container, and it comes back and tells me whether it's healthy or not. And the reason that's important is because if a container goes bad, if there's a code problem and the container starts running out of memory, then the health check will fail. And then in a clustered environment in production, Docker will kill that container and start a replacement somewhere else. So I'm getting all this dynamic organization, I'm getting all these fast starts and all that sort of stuff from my old 10-year-old application without having to go back to the code and rewrite it and make it more robust. I'm adding the robustness at the Docker layer just by having this Dockerfile here. Okay, so I'm not going to build this and run it because it's the same app ultimately, but in a clustered environment, it would give me a whole better set of options. So let's flip back here. Oh, where's my PowerPoint gone? I've got several screens up here. Okay, so we're coming towards the end here. So I will get to the Q&As just for a couple of minutes, and then anything I don't answer will go in the blog post. If you don't see it in the blog post, then feel free to reach out to me. I'll be more than happy to answer your question. So some of the key takeaways here. The first one is that this is production ready. So if you're in the Windows world, this feels like a very new technology, but Docker's already 5 years old, and it's been we've been working with Microsoft to get this into Windows for a couple of years before 2016 even launched. So when now that we're working with them on what's happening in Windows Server 2019, there's going to be 5 years of Docker technology in Windows coming soon. You've already got production support, so included in your Windows Server license, you have a Docker Basic EE Edition license. So you can run containers in production and get support from Microsoft. And any issues that they can't resolve, they work with our team. So between them, Docker and Microsoft give you production support for your apps. You've seen the choice elements, so we can take this stuff. You can run it on any cloud. You can run it on the data center. Those images you can run on Windows 10, and in the future you'll be able to run them on Server 2019 as well. The agility stuff is really important because it means you can take the applications now which are really awkward to deploy, and you can make them automated. Make the automation to make the deployment really fast and to make it safe. So built into Docker, in Swarm and in Kubernetes, there's the notion of a rolling upgrade where I go from version 1 of my app to version 2, and the orchestrator goes one container at a time, takes down the old version, starts the new one, checks that it's healthy, and rolls out. And if there's a problem, it can automatically roll back. So that sort of stuff lets you move fast and deploy safely, knowing that if there's a problem, it'll get sorted out easily. And the security part, which I'm going to cover in more detail in the next webinar, which if you go to the webinar website, it'll tell you when it's coming up. This idea of a secure software supply chain. So being able to package your application into an image and push it to a central registry means you can put an awful lot of automated security process around that. So I talked about image scanning to find vulnerabilities. That's only part of it. You can also sign your images with a digital certificate to say that you've effectively given your approval to go live. And you can construct your production environment so it will only run containers if they have if the image has been signed by the right people. So if you have auditing requirements, you get all that stuff out of the box with Docker EE, which gives you an enforceable way to do your audit. It's not just about a bunch of documents. The system physically won't let you do things that you shouldn't do. Okay, those are my contact details. So I'm elton@docker.com. You can follow me on Twitter. And then here's a bunch of links for the stuff that I've talked about today. So today's demos, all that stuff's up on GitHub. That's the wrong link, actually. That second one is .space is a workshop, like a hands-on workshop where you can go in and see how some of this stuff works yourself. I did a YouTube series talking about some of these principles in more detail. That's that MTA IT Pro. And if you want to try Docker EE, then go to trial.docker.com and we'll spin you up an instance with a whole bunch of Linux machines that you can try out for a few hours. So let's have a quick look at the chat.
We did have 4 questions that came up, but if you want to choose maybe one to get to.
Okay, I can't see any. Oh, I'm looking at chat. I'm looking at chat.
Yeah.
Sorry, okay, let's have it. This is amped. On my screen, this is tiny. Let's pop this on. Okay, can we read write from Azure storage from a Docker container? So yes, so inside your Docker container, you can do anything that you would do in a Windows service, in an ordinary Windows server. So inside your code, if you're connecting to Azure storage to read blobs or to read from Azure files, yes, you can absolutely do that. And what you would do to make it even more flexible is inside your Docker image, you would set up your configuration such that when you run in different environments, you can inject the connection details you need to get to your Azure storage container into the Docker image, so that wherever you run, you're running the same image everywhere, but you're talking to different different Azure storage accounts. Would you advise to run Docker containers in Windows Service Fabric instead of Swarm? So Service Fabric is Microsoft's orchestrator. when I talked about this stuff being portable, I talked about Docker Swarm. Kubernetes support for Windows is in beta, but it'll be in production soon. And then Service Fabric is Microsoft's orchestrator, which can run containers too. To be honest, I haven't tried Service Fabric, so I haven't used it much myself. So I don't know what the support mechanism is for Service Fabric. So I know that our customers that are using Docker EE, we have support from ourselves and from Microsoft. I'm not sure what Service Fabric does, because it's a community thing. It's a free tool, so I'm not sure how that would work, but I haven't tried it myself. How do I know which base server and features to use? Okay, so that's a good question. So I've shown different base images, Nano Server, Windows Server Core. I've shown ASPNET and IS and all those other things. You're going to know what your application needs from your existing deployment document. So, you know, if you've got a document or a set of requirements that say we need IIS and we need ASP.NET, well, that tells you need IIS and ASP.NET on Windows Server Core. I did write a blog post about this. Let me go and grab. I'll see if I can get a short link for you. So if I do, where am I going to go? Blog. Elton Dockerize Windows. I should find it. How to Dockerize Windows applications. So let me get you a short link for this. This tells you basically the things to start off with. So choosing your base image, there's some basic rules. So try Nano Server first. If you've got any of these things, then Nano Server is not going to work for you. But ideally, you want to go for the smallest base image that you can get. So let's give you a short link for that. Okay, there we go. DE6, whatever that says. That's that particular blog post, but I blog about this stuff all the time, so there's other stuff there too. Okay, I think we're done for time.
Yes.
But thank you very much for your questions. Ones that I didn't get to will go in the blog post. If you don't see your question there, then reach out to me, elton@docker.com. And yeah, thanks very much for joining.
Great. And so this concludes the webinar. Reminder that today's session has been recorded and you will receive a follow-up email to view the recording in the next 24 hours. Thank you again for joining us, and we hope you have a great day.